As you're working on page 13, you should probably start by measuring the sides. We don't have the actual shapes. They give them letter names because it shows that they're a different shape. But this would be a good way to find out if they're regular or not. Regular polygons mean they have equal sides, equal measure sides, congruent sides, as well as congruent angles all through. The only way to know really about the sides, and if they have congruent sides, they'll have congruent angles. So what you really need to do is measure the sides, see where we're at. Now on this one, number one, you would have measured around to find that this was an isosceles triangle, the longer base around it, but that these two diagonal sides, if it's laying flat on the base, are actually the same length. So I'll put those the same. Now every time you see a J, that long base is there. You got congruent sides like that. And these would all be congruent if you measure them. So it's 1, 2, 3, 4, 5, 6. It's a hexagon. And as a regular, if you measured it, you could tell they're all the same length. So is this a regular polygon? Yes, it is. How do you know? Six congruent sides. So this is called a regular hexagon. All right. Number two, is it a regular polygon? Well, if you measure it, you'd find that this side is equivalent to the ones on the I triangle, the E ones, but that the bases would be different when you measure them. So these two would be congruent to each other, but these bottom three would be congruent to each other, but the two on top would be on their own. So this one does not have equal measure sides. It doesn't have congruent sides. It is not a regular polygon. So it has two sides congruent with each other. And another three other sides. Technically, you'd say separately congruent. That's how you use the least amount of words. So we got two different congruencies going on. These are congruent. These three down here are congruent with each other, though. How do you know it's not a regular polygon? Not all sides are congruent with each other. Okay, let's do number three. This one here, you'd find that A is a square. E is an isosceles triangle. You got this and that are congruent with each other, as well as this, since A is a square. Everywhere you have the square, you're going to have congruent sides. We got those, and that, and that. The thing is, these E ones, the base of that triangle, it's an isosceles triangle, so these two are, this one is not. I put two lines there, and it shows that anything with two lines is congruent to each other. Anything with one line would be congruent to each other with the one line. But the ones are not congruent to the twos. So this one, is this a regular polygon? No, it's not. How do you know? Not all sides, same as number two, are congruent with each other. Or congruent to each other. Either of these, with or to, either of those terminologies would be a correct, accurate terminology. So we had one regular hexagon. This is a irregular pentagon. It's an irregular pentagon. So that's a regular hexagon. Irregular pentagon. What would this one be? It's got 1, 2, 3, 4, 5, 6, 7, 8 sides. So it is an irregular octagon. Octo from the Greek for 8. Irregular octagon. Those are answers for 13.